Hello, everyone. Good afternoon, good evening, good morning, whatever time it may be in Vietnam, in other countries, from where you are watching this lecture on emerging digital techniques for building surveying. My name is Henry Abanda. I am an associate professor in construction IT and also a chartered engineer with the Institution of Engineering and Technology here in the UK. I'm a fellow of the UK Advanced Higher Education Academy, and my research and teaching interests are in construction IT with focus on building information modeling. I'm based at Oxford Brookes University in the United Kingdom. I will say a bit more about the project. This is part of a non-profit educational project in the development of free online educational hub being undertaken by the Institution of Investment and Construction Management at Hanoi University of Civil Engineering in Vietnam, together with the Department of Engineering at Manchester Metropolitan University. The project is supported by the Royal Academy of Engineering in the United Kingdom. The overall goal of the project is to reduce the digital skills gap in the Southeast Asian construction industry through an open access e-learning platform. You can see the logo of all the stakeholders below. At the end of this presentation, it would be great if learners can be able to appraise the challenges associated with the surveying of buildings or properties. Secondly, learners should be able to differentiate between conventional and modern surveying techniques. And lastly, learners should be able to identify the applications of modern surveying equipment. Now, I've divided this presentation into two parts. The first part is a theory part. And of course, given the context, today I can't be saying anything about digital technology without really us getting our hands dirty at some point. So the second part will actually focus on a demonstration in practice. Now, building surveying, what is it? It is a means of providing detailed evaluation of a property's condition and involve an extensive inspection. In fact, when I use the word property, you could also say buildings, and to be more general, it could be a project. So it's a means of providing a detailed evaluation of the condition of the property through an extensive inspection. And condition there is actually talking about the state of the project or the state of a property or a building. So I would say building survey is equal to condition survey. So the keywords are assessing and recording the details about a part or whole of a property or building. Now, the most common aims of building surveying might include documenting the present condition of the property, highlighting areas of failure or concern. In fact, when we are evaluating a property or a building, one of the aims is to be able to assess the present condition with the ultimate goal of identifying failures or concerns or defects, identifying the causes of past or ongoing deterioration, identifying issues that need attention to prevent serious damage. There are times that if there is a defect on a property, if you don't take an immediate action, if you don't evaluate the property to identify the main issue, it might escalate from a minor to a major damage. Identifying things that need further inquiries to preempt problems in the future, presenting conservation and maintenance recommendations, and providing estimate of the cost of any works that may be required. The most common issues identified by condition surveys include defects, any structural movement through subsidence and settlement, deterioration due to rising damp, penetrating damp, surface interstitial condensation, rot infestations such as woodworm. I won't spend time reading all of those. Some of those stuff are obvious, and you can read them at on time. Now, typical surveying activities. Remember, we did say in one of the earlier slides that it involves intensive inspection. So the kind of activities that is involved in surveying are visual examination as opposed to invasive one where things like carpets or floors or underfloor spacings, furniture may need to be moved or taken up. So visual examination. External examination from ground level of roofs, okay, chimneys and other surfaces. The key word there is actually external examination. Now, in the third point, depending on safety and accessibility of the different parts of the property or building, an internal examination can also be conducted, especially in the roof area. Now, those are the activities. How do we carry out these activities? We do that either using what I would say traditional or manual surveying techniques, or semi-automated surveying techniques, or advanced automated surveying techniques. We're going to see the differences between these main three methods or techniques of surveying. Now, I've said traditional stroke manual or manual surveying. And this type of surveying, we literally use our eyes and then we go around the building or property. Okay, we might use things like a tape, okay, to do some measurements, okay, and to identify defects. So that's a typical defect there on that roof, where we may see it visually, okay, and go around the building. And that's me there some 20 years ago, surveying a building, literally walking from one room to the other, and then using photographs together with that side guy, using a tape. And you can imagine how long it may take to be able to complete a building or inspecting a building, identify potential defects. Now, with a semi-automated surveying, you may have you may involve the use of equipment a bit much advanced than just using the manual tape and other minor equipment. So photographs which may subsequently be annotated may be taken using a camera. You may also be using a dictaphone, a damp meter, binoculars, torch, and a shot ladder. So there's some semi-automated, there's greater involvement of use of equipment. And of course, if you think about the manual or the traditional, together with semi-automated, the disadvantages or the weaknesses is that it is error-prone, it is time-consuming, it is costly. And of course, you also have impacts, negative impacts from the weather, having to go around and having to spend too much time on site, where you can be affected, or someone surveying the building can be affected by negative weather impacts. Things like rain may hinder the smooth running or inspection process. Also safety. Imagine yourself in a room or roof. Okay? Some locations are unsafe to work in or inaccessible. And of course, when you get this kind of data through manual inspection or semi-automated techniques, it is usually very difficult to integrate that with other digital systems. I would like you to take note of that last point, limited integration capability with other systems. So you collect your data manually, it will be very, very difficult for you to be able to integrate that with other systems to be able to exploit or use the data more efficiently. And then with the advanced or automated or modern surveying techniques, we have things like the GNSS, as a global navigation satellite system, robots, drones, and 3D laser scanners. Okay, our focus will be on 3D laser scanners, although we're going to be able to say something a bit about robots and drones. So far we've covered the three major techniques of surveying buildings. Now, let's now focus on 3D laser scanning, which is a modern technique used to accurately represent physical objects. And I like that definition. It is a non-contact, non-destructive technology that digitally captures the shape of physical objects using a line of a laser. 3D laser scanners create point clouds, okay, of data from the surface of an object. In other words, 3D laser scanning is a way to capture a physical object's exact size and shape into a computer world as a digital three-dimensional representation. Now, the different types of 3D laser scanners can be classified into terrestrial laser scanners. And you can see some examples of terrestrial laser scanners there: Leica, Trimble, Faro, Topcon, Z+F. Now, what should be noted with all those from the word terrestrial is the fact that you need a stand, okay, to be able to, you need a stand to accommodate these scanners, and that stand should be located on the earth surface, on the ground, okay, what I would call technically a tripod, okay. Then we also have handheld laser scanners, the one just like you've seen there. You use you hold it with the hand instead of using a tripod. Then we have wearable scanners that you wear on your body, then you move around, scanning whatever object or environment in which you find yourself or you want to do. Then you also have mobile laser scanners. Take note of the word mobile here. It's a bit confusing with the last category of scanners. Here, literally, we're saying that the scanner is mounted on an object that is moving, such as a robot or a drone, okay? And then it can now move around and scan the intended target. Now, don't confuse mobile laser scanners with mobile apps laser scanners. Our mobile phones today have so many mobile app scanners in them. And I've just put a screenshot on the left: Metascan, 3D laser scanners, okay, Metaport, Canvas, Sidescape, Modular, Scanivers, Polycam. Those are just some of the examples. There are so many of them today. You can actually use a phone to scan some of these apps to scan a building. And then one that we used in the past is Polycam, which is one of the leading 3D laser scanning application developed specifically for iOS. Now, that last point of Polycam allows you to export your scans in over a dozen file formats, including OBJ, GLB, MBX. Those are file formats. We're going to cover that concept later on. Now, the merits of 3D laser scanning. Remember, we started off by looking at the different types of surveying, okay? We spoke about the manual, the semi-automated, and the advanced automated techniques. And then we took 3D laser scanning as one of the advanced surveying techniques, okay? And then we've seen the different types of laser scanners, categorize them into mobile, wearable, mobile applications, and terrestrial. And now we want to see the merits of 3D laser scanning over conventional or traditional surveying techniques. Usually, laser scanning is very, very efficient. Okay. For example, if you use a laser scan to scan a building, you avoid so many journeys that you have to make to site. Okay. Imagine if I were to use the manual technique that I was doing, or that I did some years ago, to survey a building. I will go into that building using a pen and paper and maybe a tape, going around identifying defects, taking notes. I may go back to the office and realize that something is missing. I have to go back. So I may end up going to the site maybe about 10 times, or to the building about 10 times to have a complete picture. But with a 3D laser scanner, you minimize the number of journey times to site. Okay, and scans can actually capture up to 1 million points data per second. Okay, and you can use, very few people can be involved in scanning a building, and it's often very, very safe for a scanning team, because you can be located at one point and be able to scan the whole building instead of having to go around or climb the building from one using a ladder. Laser scanners or laser scanning is very, very accurate. That's one of the best advantages of 3D laser scanning, very, very accurate. And of course, it is very, very safe. It is a non-contact measurement system, okay, or surveying technique. It is a non-contact, non-destructive. You don't have to touch the object during surveying. And then the applications of 3D laser scanning. So we can use it in comparing the as-built model with the digital model, okay, or virtual model. So you see on the left there, that is what is on site. Then we actually develop a digital replica, and that's what you have on the right. So you can always compare and see what are the changes. It can be used for project or progress monitoring. Okay? Imagine laser scanning a project that is evolving over time. You can always compare what you have on site with the digital equivalent or replica. And of course, you can use the scan model, okay, the point cloud data that you would have obtained from your scanning activity to generate a model that can be used for building retrofitting. The same, you can use your point cloud data obtained from laser scanning to generate a 3D model that can be used for maintenance and repairs of buildings. We can also scan historic buildings that have been there for ages, especially if it was designed with no, if it was designed long ago, and most of the time you don't have the drawings. And if the drawings even exist, they will hardly really match what is in reality or what the physical building is all about. So 3D laser scanner can be used, laser scanners can be used capturing historic buildings. And now, what is that process of scanning? You can see that, let's put a slide there. It's a bit high level. We start from data collection using the scanner. Then we process the data, we organize the data. Then it's modeled now. Then the information is extracted from the model for different applications. Now, depending on the technologies, those are the different workflows. I've just picked that from that site, Cancel. The link is below. You can actually go to a site and see the different laser scanning techniques that they've got, not in any way publicizing them. I don't know that company at all. So let me just focus on this one, which is by Faro Scanner. Of course, the activities to capture the as-built model. So we use a Faro Scanner to scan the building. And the next step is get the point cloud from the scanner that's scanning the building. You can now process this in the different software systems. Either use Faro Sim, Edgewise, or even Revit. Now, depending on the file output from the Faro Scanner, it can directly be taken to Revit, and then based on that, the 3D model is generated, and that's what we're getting at the end there. The as-built Revit model. Yeah. So remember here, we mentioned something about software tools. For us to be able to move our point cloud from Faro to any of the software, be Faro's Sim or Edgewise or Revit, the two software need to be able to communicate, need to be able to talk to each other. So I'll have to define another concept here called syntactic interoperability. Syntactic or interoperability here in a nutshell refers to the ability of two software programs to be able to communicate and exchange data with each other. Okay, and I put some references there or citations. Okay, so in other words, we are saying that for two software to be interoperable or two systems to be interoperable, they should be able to read data or exchange data. Okay, one should be able to read data from another one, and in this case, Faro, the data from Faro should be able to be read by Revit, for example. And so we'll have a table there where we've actually developed this in one of our articles that we wrote some years back. That means if I were to buy a software like Trimble Reworks, okay, which is a software that we use in processing point cloud data, I'll need to first of all find out the type of files that it reads and the type of files that it generates. So that if I were to get my point cloud data into Trimble Reworks, I should know exactly what I'm going to take it to Revit or ArchiCAD and stuff like that. Okay, so we have the 3D laser scanners on the extreme left. Then they tell you the different type of software that can actually read data from those 3D laser scanners. So if you use Trimble TX, you are likely going to take the data into Trimble Reworks. Faro can go to Faro Sim. So, and then Leica Cyclone. But it's still another table just for your learning. And to simplify the workflow here, it's like we get a scanner like a Trimble TX8, we scan our building, then we process the data, then we can now export into different software. We export the data into different software, be it Revit, SketchUp, or any CAD software. Now, the reason I've used Trimble TX in there is because we have it in our laboratory, our BIM laboratory. Now, that's just a simplified one that I need to show, which is exactly what I'm going to do in our part 2 of this presentation. So we're going to get our point cloud data from Autodesk Recap and then take into Revit, then use it in Revit to develop a BIM model, and then based on that BIM model, it can be used for different applications, what I would generally call NG modeling. These applications could be cost plans, could be project programming, could be rehabilitation, facilities management, documentation purposes, all the kind, even health and safety, all the kind of applications we think of in practice, we call that N, okay? ND modeling. But then our focus will just be on how to get point cloud data from Autodesk Recap to Revit. And of course, it depends on the file format, the concept of interoperability. If we have our point cloud in Recap, how does it get into Revit? We have to export it in the RCP format. Okay. So this one is part 2, which is demonstration now. Part 2 is demonstration. Okay. So before I move on to this demo, I would like, first of all, to again emphasize on this. Okay, we are now focusing on our 3D laser scanning, where we said we have to capture the data of the building or property using a laser scanner, 3D laser scanner. And we've seen so many of them. Trimble TX8 is one of them, Faro is one of them, Leica is one of them. And we are saying that once you capture that data, once you scan the building, okay, you can remove the data from it, which is a point cloud data, and then take it into a software. Okay, that software could be Trimble Reworks, okay, and then you process it before taking on to Revit. But in this case, we want to use data from Autodesk Recap, partly because I don't have any point cloud data anywhere. And those that I've seen on the internet, I would rather want to share that with you to use instead of taking what is on the internet or in YouTube and using, because maybe violating some copyrights or copyrights terms there. So I would rather use the point cloud data that is in Recap. Okay. So at the end of this demo, you should be able to import a point cloud data from Autodesk Recap into Revit, explore the point cloud model, do some light adjustments like setting levels, and then model walls and other elements. Most importantly, I would advise you to watch the extended detailed video that I've actually copied from YouTube, that I've provided a link from YouTube. That video is not produced by myself. It's a very, very great video that I would like everyone to watch. Of course, what I'm showing you in this demo is just a scratch on the surface. It's not detailed. Okay, so let's now go to it. This is, let me close this and then start it again. Autodesk Recap, this is it here. If you install a Recap for students, if you have a student account, all Autodesk products are, the Autodesk can give you a license for up to a year. If you're a student, you can download most Autodesk products. So Autodesk Recap is one of them. I've not paid for it. I've just used my staff account to get the license for this. So this is Autodesk Recap, and this is a sample project that comes with it. Okay, so this is a sample project, and that sample project is a point cloud data. Look at this. So I'm just going to browse this and see the kind of building, okay, the kind of model. To be honest, I don't know much about this building. I don't know whether it's an educational, a factory, or a warehouse. You can see the entrance, the west. It looks like a lab, to be honest. Okay, so that's it there. Now, what I've done is I've actually saved this in RCP format. So once I've done that, I now go to Revit, okay? And then I create a new project. That is my Revit, which all of us should know. I'm going to create a new project. Okay. Now this is our Revit interface. I'm now going to go into Insert. And once I go into Insert, you can insert all other files. So I'm going to choose Point Cloud. Now when I go Point Cloud, this is the Autodesk recap sample project, okay, that downloaded. So I'm just going to click and I leave it auto center to center. That is a model then, okay? And again, I can go to 3D to view it. I can zoom to see. So we can see that. So what I'm going to do now, I really need to understand this building. I've not been able to understand this building, to be honest. I don't know what they have on top of the building. Are there solar panels or what? I have no idea. So what I'm going to do now is see what is inside to see if there are levels. So I may have to go to section box. Yeah. And then I have that. If I click that, then I go like this. Yeah. So there is no other floor. So it looks more like a workshop, something like that. Yeah. And this is a door. Yeah. And this, you have wall that goes right up to this point. Yeah. So let me take it back again up by using this. Yeah. I can also do like this to see what is here. Yeah, there's no other level. Okay, so I'm sure there's no other level now. Okay. So once I have that, I should take note that there's something like a window here and a door here. Okay. So the next thing I want to do is to check the levels, is to set the levels. Remember, my points here, import this, which I've done. Okay. Through linking though, explore the point cloud I've done. I'm going to do some light adjustments. So I'm going to go back to this, and then go to my east elevation. Okay. I can't find my, okay, that's my model then. Now, if I have it here, maybe I'll have to take this one off so that it aligns with that. It's not going to be accurate, so I'm going to pull this in. Today my mouse has not been behaving well, so if it does not, please accept my apologies. Yeah, so that is our level 1. You can see that there's a gap here, and I'm going to pull it down so that it goes a bit. Yeah, so I have something there like that. This one at this lining here, maybe our level is here because it seems as if, yeah, that is the top of the walls, and those may be solar panels, something like that. I'm going to leave it such. Then I make sure I do the same. Then go to the south elevation. Then go to the west. Now, so that's that. I've sorted those ones. Now, if I go back to this, you see it's behaving a type. When I hover around, it changes. I don't want that. If I click on this, and then I'm on modify point clouds, I can pin that. Okay, so that is not behaving like that, you see. So I can actually pin it there. Yep. So I have this now. I want to be able to see these walls and retrace over it. Okay, so I'll have to go to view range. Let me see. So take note of what is happening here. If I put 1,200 here, or 1,300, you can see that the lines of the walls are becoming a bit clearer. Yeah, I think 1,400 is okay. Let me see. 1,600. No, that's too much. Let me change it to 1,450. Yeah, I think I'm going to go for 1,450. Now, but then let's go back to our recap model to really see. Yeah, okay. So you can see these are straight walls, straight walls, straight walls. So, and there's a door here. So I'm just going to leave it as such and then use this as my wall. Again, I'm on level 0. Yeah, so I'm going to go to my wall. I'm going to click the wall here. Okay, click there, speaking. Click there. Like this. Turn like this. And then I'm going to go like this. Okay, since it's straight wall. Like that. And then like that. Come out of there. Then I may go to architecture, pick my door, double door. I'm just going to use that on and put here. I may want to flip it so that it opens outward. Remember, there was a window here. Okay, so I'm just going to put a single window here. Okay. Now, once I have that, I can now go to my 3D view. Oops, my walls are actually internal, so there's a way and easy way of flipping it, flipping the wall. So I'm just going to click like this and then get this arrow. Flip. So yep. So that's what we've got. Okay. So let me go back now to my, let me click on this word and make sure that the top constraint is on level 1. Yep. Yep. Okay. I have this. So what I'm going to do now is to put my roof top of this. And of course, as I said, I don't really know what this building is all about. I'm just going to put a roof, assuming that these are solar panels or something else. So let me go back and then I put my roof. It's going to be a flat roof. So I'm going to do that. Yes. Okay, let me just go back to level 1 and see what is there. So even if I stay here and say yes, and I go architecture, I get my roof by footprint, yes. I'm going to give another of say 100. It really depends on the convention that you're using. Okay, the standard. So if I say this, all right, there's an issue. So to sort that one out, I need to do a kind of extension. Yeah, I will need to use a model line like this. And then just like in AutoCAD, we can extend that. Okay. And then here we can use this and that. Oops. We're supposed to Let me repeat it. There's an error now. I'm going to take a footprint. Yes. Put 100 there. Then go this way, this way, this way, this way. And then, yeah, that. Yeah. I'm going to say touch. And then I can now go to my 3D model. And then I see what is there. I can't find my roof. So maybe it's embedded. So what I need to do now is to remove the point cloud. To do that, I go to manage, and then manage links, point cloud, remove. Okay. I'm also going to remove this section box by going to, yeah. So that's the roof that is there. Now, but then I don't want this. I'm rather going to remove that. I just want to do it as it is. So once I do that and I click on these lines, I can say remove slope. Yep. So that's a flat roof now. So that is basically, so we could add other components just as we would have done in a typical Revit modeling. Okay. So that is how we bring our point cloud from Autodesk Revit or Autodesk Recap into Revit, and then use a kind of tracing to be able to generate a model like this. And based on this, now we can do different things. We can do quantity takeoffs. We can export it. We can even evaluate the embodied energy of this model. We can take it to other software systems. So basically, I won't say I have to go into details about this, just to give you a flavor rather than just leaving everything at a very theoretical level. Now, what I would advise you is to watch this video. This is a must watch. It's going to blow your mind into the world of 3D laser scanning. Okay. Then also, there are some resources here. It's been difficult getting point cloud data from the internet. So, but then I've given some links here that can actually allow you to be able to get point cloud data to be able to use. If you don't have a laser scanner, I also advise you to play with the mobile phones to see the kind of mobile app scanners that we have. Then we have some of these resources, some of them I'm going to share with you, and some of them you can access them directly. This one is written by myself and some of my colleagues, and this one as well, my previous students. I'm going to attach this and the learning resources that will be shared with you. Thank you very much. Thank you for listening. And if you have any questions with this presentation, please, by all means, get in touch. Thank you very much. Bye for now.